Awesome, it worked. AV worked for once in our life. Cool. So welcome, everybody. I'm going to be talking about a lot of basically the methodologies and practices that we do at Bitly to move quickly without breaking the internet, because not trivial amount of that goes through our servers. So before I get into the meat of that, let me get something out of the way that tends to come up with Bitly. So just out of curiosity, how many people here are aware of at least Bitly in the form of like short links, right? Awesome, cool. A lot of times that gets reacted just like, really, seriously, how is that a company, right? Like I can literally write a URL shortener before you're done with this talk. How is that a thing? It's just child's play, come on. And even then, how do you make money off of it? Like even if I grant that like doing this with high availability and doing it at a large scale is difficult, like how do you possibly make money off of short links? Well, the short answer is branding. So we have tools for basically having companies host their own URL shorteners through us. So you can see there, ESPN links, those are us. And analytics. So every click that goes through Bitly, we do a bunch of tracking and we do a bunch of number crunching to keep track of what's going on. So let's talk from a technical perspective about what actually kind of challenges we're dealing with. So every single day, we see 200 million redirects, 20 million shortens. We crawl about 4 million pages on the web. Just to roll that up for some people, that works out to about 6 billion clicks a month. And we do that with about 400 servers spread across 2 data centers with 25 engineers doing 20+ deploys every day. Right? So that's a lot of change going out all the time. So let's get into kind of how we think about that and how we deal with that, and some of the challenges involved, right? So when you talk about doing something like 20 deploys every day, there's a tension that's going on there, right? On one hand, you want to be keeping things safe, right? If those short links that we have all over the web, like at this point, there are literally tens of billions of Bitly links, and it's embedded throughout the web, right? So if those break, nobody's happy, right? Like that's a really bad day. People are pissed off, right? It's really no good. I've been there when we had outages. It's bad. The flip side is we need to ship things quickly, right? I mean, just like at the end of the day, to be frank, we're a VC-backed startup, right? Either we grow and learn or die. That's just how the business works. We have competitors, and we have stuff we want to do ourselves and that our customers want. So we have to keep shipping stuff. So it leads to these really conflicting desires, because a lot of things you do to move quickly tends to break stuff, right? Like the classic Facebook, like move fast and break shit, right? Like that's a problem for us. So this is going to be talking about basically, it's just going to be kind of like a shotgun of stuff that we do to deal with that. And at the top of the list is automation. We automate everything. And a lot of it is just because if we didn't, we would break down crying. There's just no way this stuff can work without it. So of those 400 servers I mentioned, 200 of those are in EC2. And at that scale, we get an email at least once a week saying, hey, your server's going to go away in a few weeks. And then there's probably another 1 or 2 that just go away without any warning, right? Like, that's a thing that we have to deal with. If we were manually replacing and provisioning those servers, we would need an army of sysadmins, which just isn't practical both in terms of like salaries that we can pay, as well as just like a thing to manage, right? Like that's just nuts. Another part of why we automate everything is just computers are faster, right? At the end of the day, a lot of what traditional sysadmins do is fairly kind of rote mechanical work, right? Like 90% of provisioning a server is just doing the same things over and over and over again and not messing up. Computers are a lot better at doing that and doing it quickly, right? So as an example, right now for us, and we haven't actually spent a whole lot of time optimizing this, for us to go from making the API request to provision an EC2 server to something live handling production data is about 10 minutes. If somebody were to do all the work that happens in that process manually, you're talking about at least a day of somebody being completely focused on that work. And they probably are going to mess something up in that process. Which kind of gets to the next part of why we really like automation, is computers are a lot more consistent than humans, right? They have limitations as far as like pattern recognition and flexibility, but if you give them the same inputs and the same environment to work in, it's really, really likely that they're going to do exactly what they did yesterday, today, right? So that generally is a nice attribute, and that I can trust that the script that I ran yesterday is going to work the same today. But that gets really powerful when you have a solid review and testing process in place, right? So there's a certain amount that I can do review and testing with humans, but since they're fuzzy and they're not going to perfectly duplicate things every time, just because somebody deployed something yesterday, I'm not going to be super confident that they're going to get it perfect today. On the other hand, if I have a script that went through a review process and worked in dev and worked in staging and worked in production yesterday, I'm super confident that assuming the environment hasn't changed, it's going to work exactly the same today, which can be really powerful for basically getting stuff done quickly. And then taking things beyond deployment, we really take automation throughout everything. So this is Jenkins. For us, we actually have a bit like a little process. So as I'll get into, we use GitHub pull requests for basically all of our code review. So anytime code gets pushed to an open pull request, the Jenkins will run our automated tests against that code. It's one of those things that makes a lot of information available to people very quickly that otherwise would take a lot more time. Additionally, operational tasks. Pretty much anytime, the first time we do a particular operational task, like let's say, I don't know, expanding the resources available to a database or something. We might do that manually. By the second time we do it, we automate it, because at that point, it's very likely that there'll be a third time and a fourth time and a fifth time, and we're lazy, right? The classic, good developers are lazy developers, and they don't want to do things a bunch of times. We very much take that to heart, especially for operational tasks. Something else that we think about a lot at Bitly is state management. So I have a bit of a story around this. So about a year and a half ago, when I was first interviewing at Bitly, something that came up in the conversations will generally come up in like a technical interview is the question of how they manage kind of their STM, like how they manage code control. And it came up in that conversation that Bitly manages all their code, both systems code and basically configuration management code, for practical purposes, imagine Chef and Puppet, in one giant monolithic repo. And at first I was like, what? That sounds insane. How is that not a giant rat's nest where you can't find anything and manage anything? But we talked about it for a bit, and that kind of came around to, this isn't so bad, right? If you have some practices in place that enforce some discipline so that you can basically manage that tendency for things to decay into a rat's nest, you get this really powerful side effect of having a unified view of the world, of code and config being joined. Any given commit in our repository is a complete snapshot of the state of our system minus data. So that's really powerful as far as if you're trying to either go back in time and figure out what things were going on, or if you need to do a rollback or bailout of a bad deploy. You don't have to go through and figure out like, okay, I don't know how many have gone through like, okay, we did a deploy, things are really bad, we have to roll back, right? The first step in that is like, okay, where do we roll back to? Because it's not necessarily the last commit. If you have things coming from a dozen repos, you have to do that a dozen times now, which is not exciting when things are on fire. If you have everything in one repo, you can kind of just roll back. And there are some scaling limitations to that, but a quirk we've found from talking to people is like, this is actually how, to a certain degree, Google and Facebook also do things, right? And for much of the same reasons. So you have some kind of interesting benefits there. The next really fundamental way we look at things that has deep implications for everything we do is service-oriented architecture. So if you look at Bitly from a code perspective, there is no one Bitly application. There are dozens of little services that focus on particular tasks that then tie together in relatively loose ways to make the system overall. And this gives us a ton of nice benefits. We also cheat a little bit in making that easier for us, but I'm not going to talk about that too much in this talk. So one of the biggest things for us is what failure looks like in the context of SOA. If in a monolithic application, what tends to happen is if there's let's say there's a bad deploy, and let's say there's some kind of configuration problem where you can't talk to caching or something like that, right? Your entire system goes down, hard down. In an SOA setup, since you have isolation between these different services and very specific boundaries between them, it's extremely unlikely that you'll take down the entire system. Most of the time what will happen is you'll just have a particular service go down, and you'll certainly have a degraded user experience, right? A particular feature won't work, but the service overall will keep going, which is really important for us because, again, not breaking the internet. Another nice side effect of this kind of setup is when we do a deploy, like one of those 20+ deploys a day, we're never deploying to all 400 servers at once. Aside from the actual computational task that's involved, which is non-trivial in that, that's potentially a very destabilizing thing to do. But since everything is broken down into services where there's specific hardware handling different services, we only need to deploy to the servers where the service runs.
How do you square the circle around the fact that you have one big repo for your code and you want to deploy any bits of it to a lot of servers?
Sure. So the question was, if we have one big repo for all of our code, but we only want certain bits of that code running on any given server, how do we figure that out? The practical answer to that is, while we have one big repo, we organize things. Within that repo, there's basically a bunch of top-level directories, and those top-level directories are basically services. So there's no cross-communication or library sharing between those, aside from through normal system stuff. So most of our stuff's Python. So if there's something that needs to be shared across services, it gets installed as a Python package through our deploy process, and that's how that gets shared. And then basically we have our configuration management system is homegrown in this crazy pile of Bash and Python. For practical purposes, from a high enough level, you can think of it as Chef and Puppet. And basically we have a system of tags for the servers. So kind of like roles and Chef, and I imagine Puppet has something similar. I haven't worked with it that much. To basically say, these are the services that should run in this particular box. And based on that, it will kind of start up or tear down services accordingly. Is that cool? Another really powerful aspect of service-oriented architecture is it makes everything easier to understand, both when you're debugging and when you're architecting systems. You can think of this as like functions and classes in your code, right? Like, while you technically could write whatever application you're going to write is just one giant pile of serially executing code, you'll go insane trying to keep track of anything longer than a few hundred lines, right? So we have these abstractions that allow you to isolate functionality into specific little pieces, and then either pay attention to how the pieces fit together or the implementation inside of one individual piece, but not having to keep the whole picture in your head at once. Similarly, services give you a similar kind of abstraction in that you can either look at a systematic level, right? If you just know stuff's broken, but I'm not sure what is actually the problem, you can look at a system level to say what piece is likely broken. And then when you figure out that piece, you can kind of invert how you're looking at those API boundaries and just look inside that service and see what's going on, which is really powerful for understanding stuff. And this takes things a step further as your code base ages. So Bitly's been around for about 5 years. There's a lot of code there. And I've been there for 1.5 years, and I still don't know all the code, right? It's a lot. But that's OK, because most of our services are less than a few hundred lines on their own. So even if you've never touched a service, you can just dive into it and understand it very quickly and deal with that as you need to. Another nice benefit of this setup is it makes it very easy to use the right tool for the right job. So as I've kind of alluded to, our default at Bitly is Python, just because we like it, we find it readable, we can develop in it quickly. But there's things that it's maybe not always the best tool for, right? If you have to do really complex concurrency, that is miserable in Python. If you have to iterate over things really quickly, it's just not that good at it. So when we run into situations where Python isn't the right tool for the right job, we can pull in other things very easily because our service boundaries are just kind of platform agnostic, right? It's just JSON either through HTTP calls or pub/sub queues. So for example, we need something to be faster doing crazy concurrency, we tend to use Go. We have a search system where Lucene is really appealing, so we use Java there, right? We can just plug those in as we need to. That has some other potential risks as far as using all of the tools and having to keep that in your head. But with some discipline, it's not so bad. Excuse me. Similarly, we can use data stores as it makes sense for a given service. So part of the isolation between systems is if they need to persist data, they each take care of that persistence on their own, so our data is massively denormalized. This is one of the ways we can cheat in that our data is effectively immutable since links don't change and clicks don't change. But there are ways to do this if you do have more immutable data. But accordingly, each service can have a data store that makes sense on its own. So we have one service that's basically a metadata that we get from crawling pages, because doing the actual crawl is a fairly expensive operation. And that's basically just a key value thing with billions of things, right? So that kind of sounds like React, so we just use React there. There's another service where we kind of keep track of real-time click rates on, and there, Redis is a really good fit because we want it to be fast. We care about, like, it's nice to have those complex data structures, but the overall data set's not going to be that big, so it can fit in memory. So we can use the right tool for the right job. Similarly, we can use suit hardware as needed, right? Like our default is something that looks like a C1 medium, or I guess the new one's C3 large on EC2, just because we've optimized for cost performance on those. But some things need a lot of memory, or they need SSDs, right? So we can build things to accommodate like that. Similarly, we can make decisions as far as what data center it runs in, as far as having actual hardware versus the virtualization. We can also scale services as needed, right? So let's say we make a change that means that we're going to be crawling twice as many things as we previously used to. We can just add more resources and scale that crawling service without having to have anything else care about that, right? Since you have those boundaries and separations of concerns, you can deal with those problems just where they happen without having to worry about too many consequences to other parts of the system. Which again, when you're not worried about, when you have those clean isolations, keeps things stable. Yep.
Are you just limited to EC2 or any other public cloud? Can you use any other public cloud?
Right now we have tooling for EC2, and so we're in EC2 and we have a effectively dedicated hardware within a VeriSign data center. It's our other data center. We potentially could move into other clouds, but we haven't built the tooling for that.
Just curious, what are you crawling for?
To get extra context on links. So from just actual redirects that we do, we get some context just based on what the browser sends as part of that redirect process. But we usually can't tell what the page is about. So we'll crawl a bunch of pages and do a bunch of analysis to say like what the topic of this page is, maybe pictures, titles, stuff like that. And the last thing that we get from this is significant cost savings, right? By being able to very specifically tailor hardware and optimizations to given particular services that are focused on specific tasks, we can save a ton of money because we're not having a bunch of stuff sitting around not getting used. So we can kind of tailor things as it needs to be tailored. The next thing that we think about is async being better than synchronous, except when it isn't. At this point, you might think it's going to go into some tirade about some hipster bullshit like Node.js or whatever. Thankfully, we're talking at a different level, something more architectural, right? When we look at building systems, we try and ask, can this look more like sending letters in the mail than two people having a conversation, right? Because you get a bunch of benefits by having that different relationship between systems. In particular, you get better isolation and looser coupling, right? So, accordingly, you get more flexibility. And a lot of that comes down to what error and load situations look like, right? So let's say our metric system that's keeping track of, like our time series database that keeps track of how many clicks something has gotten in a given time period. So that's having some kind of capacity issue, and it can't keep track of just the stream of data coming at it. If you're dealing with some kind of synchronous process, now suddenly that capacity issue or that failure is a problem for the upstream system that's handling the redirects, that's producing the data for that system. But if you have things going through something that's more asynchronous, and particularly something with queues, the upstream system doesn't need to care, right? It can keep advertising that things have happened, and that can just pile up for a while the downstream system works through whatever it needs to, and then can just work through that backlog as it needs to. The gotcha here, that situation of except when it isn't, is when you care a lot about consistency. So kind of to give you a practical example, when you shorten a link on Bitly, everything that happens there at a systematic level is completely synchronous, right? So that goes through a bunch of layers of our architecture, and that's all either HTTP, basically blocking HTTP calls or blocking database calls. And the reason for that is we care a ton about consistency here, right? Because we can't give the same bit.ly hash to 2 different long URLs because that's kind of like crossing the streams, right? Like just, that doesn't work, the universe kind of ends. And similarly, we much prefer to say, hey, we had a problem, we couldn't give you a bit.ly link, than to give you a bit.ly link that doesn't work. You technically could do that in an asynchronous way, but keeping track of all those failure scenarios gets much more complicated, and doing that in a timely manner gets much more complicated, right? We care about this being very fast. On the other hand, for our metrics incrementing, if there's a few seconds or maybe even a minute of delay in updating our stats pages, But on the other hand, we care about redirecting users really quickly, right? So we don't, if there's some problem in our metric system, we don't want to have the redirects get slowed down or broken, right? Our metric system failing should never be the reason that redirects don't work. So by making that an asynchronous process, it makes it very easy to get that isolation and that kind of loose coupling between there. One of the other things that can be nice, kind of related to loose coupling, is when you have things be asynchronous, it's much easier to kind of tee off those streams to make copies of them, which I'll get into a bit. So the way we actually go about doing a lot of this asynchronous stuff at architectural level is a system called NSQ. It's an open source distributed messaging platform that we've built and released. You might be looking at me and hearing distributed real-time messaging. What on earth does that actually mean? I'm not going to go super deep into it, but we can go through some features. So NSQ uses pub-sub messaging semantics. You publish messages to a topic, and then you can have channels, which you can kind of think of as like copies of that topic for a given purpose, which then have a set of consumers. It's distributed, so there's no single point of failure, and there's no central bottlenecks. You don't need to worry about having your AMPQ server fill up and fall over because it's out of memory, or it's out of Erlang processes. Similarly, you don't have to worry about like the physical NIC card on a given box getting saturated. You have some other gotchas in that, like there's no strong ordering, but depends on the use case. The other thing that's nice here is there's dynamic configuration. So if you're going to add new channels or topics, that all happens at runtime. You don't have to worry about doing complicated ordered deploys to manage that. And as the name kind of suggests, there are queuing of messages. So in addition to those pub-sub semantics, as I've kind of alluded to, if the consumers can't keep up with the publishers, it'll kind of just back up for a while. And you can set like high watermarks where it'll go from memory onto disk so that your server isn't falling over because you used all the memory, which we've seen and can be entertaining, but unfortunate. And it also can have at least once delivery guarantees. There's a few different kind of architectures that you can do with NSQ. It's kind of like a set of tools, and there's different ways you can use it, but you can use it in ways where you have at least once guarantees. People sometimes ask about only once guarantees, and that's kind of a distributed systems problem. If that's not possible, if you're interested, we can talk later. If you're interested in NSQ, you can go check it out on GitHub. There's some pretty solid documentation, and there's actually a pretty decent community of people using it in addition to us. And if you want to talk about it more, talk to me afterwards. I'll hang out for a while. The next thing that we think about when we think about how do we keep moving fast without breaking stuff is user interfaces. User interfaces provide a few things, right? They make things discoverable, and they make things accessible, and they give you the right info at the right time. So here's some examples of that. We have something internally called Deploy UI. We would open source it, but it's so specific to our weirdo deployment system that doesn't make sense. It's really a thin wrapper around our deployment system. But it illustrates a lot of this stuff nicely, right? For developers who aren't necessarily heads deep in ops world, it makes it very easy for them to push out code in a relatively safe way. You can just here say, is this thing working? Awesome. You can say what servers you want to deploy to, what code you want to push there. Right here, you can just say, like, I want this branch for this user, and it will auto-populate open pull requests, and give a comment about why you're doing it. Because when you're deploying and things break, it can be nice to have that extra context. And then also kind of give you a recent history about deploys. Again, is nice if you're on call and suddenly get 1,000 Nagios alerts saying, hey, the world's broken. If somebody just did a deploy, might be related. Similarly, if you're about to go do a deploy and you see somebody's doing a deploy to the servers that you want to deploy to, you should probably go talk to that person because you might step on each other's toes. So just a lot of, again, right information at the right time and make it easy for people to do things. Another thing that's a really big UI for us is Fabric. I imagine most people in this audience are familiar with it. If not, you can kind of think of it as Bash over SSH with a bit of Python mixed in. Basically, it's a very easy command line interface for managing a bunch of stuff remotely in a procedural way. So that this deploy UI is actually just a thin wrapper on top of the deploy command within our Fabric setup. There's a bunch of other common operational tasks that you can do through Fabric as far as like taking stuff out of the load balancer and whatnot. This is kind of, you can think of as affordance. Different people want to work in different ways. So some people do deploys to the UI, some people do deploys through Fabric. It just makes sense for different people. NSQ has a very nice admin that is also open source. Again, you can kind of think of the right info at the right time. So this is looking at the page for a topic, so you can see what servers are producing a given topic. You can kind of see some stuff out of Graphite as far as queue depths and stuff like that. Pretty much if any of these lines are going up and to the right, something's probably broken. And you can drill down into the channels. Again, you can see the individual consumers, and you can have the right context on whether or not something's broken, or if something is broken, where specifically the problem is. And you can do some operational tests in here, which are convenient, right? So let's say you're killing a system, nobody's going to be consuming this topic anymore. You can kill those servers and delete the topic through here. On the channel screen, you can also do stuff like pause channels. So let's say you want to do some kind of database maintenance where you'd be nice to not have any writes going on. You can just pause the channel, be confident that all the writes going into that system are not getting dropped, but not going into the system. Do your maintenance, and then resume the channel, and the world is good. Again, right information, right time, tools that make things easier to use. We use the GitHub status API, commit status API. So like I said, for all open pull requests we have, Jenkins does a build. And when it does that build, it reports it back into GitHub. So when you're looking at that pull request in a code review, you can see, oh, hey, Jenkins says your stuff is broken. Fix that, right? So this goes a long way to helping us not merge broken code, and it makes it really easy for us to be lazy, right? Nobody wants to have to, like when they're doing the code review, remember to go over to Jenkins, see if the build worked, then come back, right? This way they can just see, is it green or not? It's great. Sorry, just highlighting the bits there. Something else that we did recently, so as I imagine a bunch of you have either seen or even dealt with, there's been somebody going around giving some extortion threats and doing denial of service attacks. We got some of those. So we have a bunch of disaster recovery plans. One of the things we learned in that process is that when it's 4 o'clock in the morning and you're groggy and you just got paged saying the world's broken, you might take you a while to figure out where all the stuff is to engage the disaster recovery plans. So we built something called the red button at UI. This makes it really easy to A, wake up the rest of the ops team to help out, and then B, engage the disaster recovery plan. You know, again, making things easy. And this was something that one of our engineers built in like 2 or 3 days, right, using the tools that we already had. So it doesn't need to be anything crazy or complicated, but especially if you're going down the path of automating as much as you can, it makes it really easy to build these things as you need them. The next big piece of how we do things is peer review. Like I mentioned, we use GitHub pretty heavily. And a lot of the process around this is kind of interesting in that this is one of those places where you can run into the danger of getting into this really draconian, heavy-handed, like heavy process stuff. But we have just one rule that everything else falls out from as a side effect. It's only one formal rule. And that is, if you wrote the code, you are not allowed to hit that green button, right? So this has a bunch of wonderful side effects. My favorite of which is it moves the worst problems that you have around this kind of stuff to better places, right? When it's the end of the day and somebody pushed out a change that broke and you just need to push out a one-line change to fix it. Oh, yep.
So how does that work if you're paged before in the morning? Do you have to page someone else to approve a change?
Potentially. So it depends on what's going on. I mean, we definitely do have the attitude of, while we have an on-call rotation, which is a fixed set of people, if your code breaks, you're getting a phone call.
No, I mean, like, if you're paged, you can fix something, but then you need someone to review it.
Potentially. We are, kind of where I was going with that is, culturally for us, it's very okay to wake up other people if you need to. The other side is, for certain scales of changes, it's okay to push out code that hasn't been merged yet. A lot of times we'll soak code in production as part of our validation steps before it gets merged. The idea here is that master should always be safe, right? So if a lot of times, most of the time the answer when somebody does get paged in the morning, it's not a code change, it's a rollback, right? And part of how we can do that at 4 o'clock in the morning without somebody else there is trusting that master is safe. This is how we guarantee that. But in the case where there are other people around and we do have that one-line change to fix stuff that you probably have a typo in because there's always one in a one-line change, this moves us to a better place. Instead of pushing it out and making stuff worse, your problem now is to find somebody in the office, tap them on the shoulder, say, look at this. They'll find the typo, you fix it, and then you push it out, right? It makes it a better situation. Something that you might have noticed is the title slide for this section was peer review and not code review. And the reason for that is the scope for the review is wider than just the code. We'll take a lot of operational and architectural concerns as part of that review. So a lot of times what we'll do, I mean, obviously it depends on the scale of the change. Some changes are just minor code changes, don't have any operational change involved. Awesome, great, easy. When, let's say, you're launching a new system, we'll actually enumerate any kind of operational tasks that are involved in having that system go out as checklists as part of the code review. And when somebody's reviewing that code, they are signing off both on the process that's proposed as well as the code itself. This has saved us a ton of headaches and time. Kind of examples of that is anytime where rolling out something actually has some kind of order, like the order dependencies, this is really good for fleshing that out and making sure.
Do you find that since you're doing that many deploys a day that you're less likely to have errors because you're deploying such small incremental changes at a time? Or
Yes.
Do you find that
Yeah, no, I mean, that's something that, yeah, I don't highlight very well here, I guess explicitly, but we are very much of the attitude that ideally deploy should be non-events, right? Deploy should be as small as possible, therefore they're going to least likely break things, therefore they're not scary, right? There's some more stuff we do kind of in that vein, but yes.
So you were saying, is it like some type of hierarchical structure, or because of how you have that set up that anyone really has the ability to deploy it once it's been curated?
Everybody has the ability to deploy pretty much right away. We do some permissioning around. In that deploy UI, we do have some permissioning controls about what servers people can deploy to, but we are fairly liberal about opening it up as people need. So it's more making sure you can't make easy accidents as opposed to preventing people from doing stuff. Generally, our attitude is things should be as self-service as possible. This also gets to our next point, is since all these code reviews, and this is a little bit of cheating over our size, right? So Bitly overall is about a 50-person company. Of that's about 20 engineers. So enough people where if you go on vacation, it's not a problem, but big enough where you know everybody and you can keep track of roughly what everybody's doing. But since these pull requests are open to everybody, they're also a really good mechanism for cross-team sharing. Most of the time as something's going out, especially if it has ops implications, even somebody on my team, the application engineering, kind of think of back-end business logic. Most of the time, somebody from ops will at least look over it and make sure there's no like, oh, hey, that's going to cause problems. Let's talk about that, right? Like, so, yep.
So you said how many engineers, how many ops, how many developers?
We don't really make that distinction. Right, so the way we handle that is we have what we call our ops infrastructure team. So they're the owners of traditional ops, like keep the servers up kind of stuff. But they also are responsible for like NSQ and a lot of our database stuff and even some kind of internal tooling stuff. And our bias is very much towards hiring engineers who do system and stuff than the other way around. Yep. So for us, it's not like we very much try and avoid situations where we're in the mindset of where we're throwing shit over the wall, right? It's very much a shared responsibility kind of attitude. Which does actually get to the next bit of how we approach things, as far as how we handle architecture and planning. This is another place where you can very easily get into a place where you get very draconian and things feel heavy and it's hard to do stuff. But we try and remain diligent while keeping things lightweight. And the way we do that is basically by asking a series of questions. And, there's no like binder of questions, right? Like I'm literally going to go through the questions we ask. And this is often takes the form of like some ops people and some other people who are involved in the project sitting in front of a whiteboard and having a conversation. Right? Like this is like an hour-long exercise. It's not huge. The first thing that we usually ask is, how is this going to be backwards compatible? right? If there are any kind of public-facing API changes are a whole other beast, largely in that you can't do them, at least breaking changes, at least not easily. Something we've learned over the years, if you publish an API, people will make calls matching that API until the end of time. How much you care about may be a different question, but they will make those calls. Anyway, internally, everything has to be backwards compatible. And the main reason for that is deploys aren't instant, right? Just as a practical reality, if you're deploying to a cluster of 24 servers, it's not going to happen at once. You're going to have at least 2 versions of code existing in production at the same time. Those have to be able to play nice with each other. And most of the time, making that backwards compatibility work isn't too bad. It's just one of those things you have to think of up front. Similarly, having that backwards compatibility in place makes rollouts and rollbacks and bailouts are much easier, right? If things are backwards compatible with how they were, just making everything back to how it was, it's probably fine. The next thing is that we think about is how are we going to do this without downtime? There may have been 1 or 2 small exceptions at some point in at least history, but at this point for us, outages for system updates are not okay. Excuse me. We're willing to do a fair amount of work to make sure that we can do it, make whatever change we need to make without downtime. But most of the time, it's actually not as bad as it seems, especially when you have that SOA kind of set up, and especially if the interfaces between the systems you're dealing with are those asynchronous queues, everything gets much easier. An example here is we have this user history system that's based on this sharded Mongo setup, and it basically wasn't going to scale as it was set up. So what we were able to do is stand up a new cluster, have the writes get copied, so we're dual writing into both systems, and that's easy to do with NSQ. Move data over from the old system to the new one from before the time we started dual writing, and then once that's done, just move over the reads as we want, right? So that's when we had no downtime, even no write outage. We completely moved from one physical cluster to another, and it's completely transparent to users. And it wasn't that, it was more work, certainly, but it wasn't that much more work for us. And again, it's one of those things where when you ask that question up front, building the system, then go realizing, oh, wow, this is going to cause us trouble. How do we deal with it, right? The next thing that comes up, and this is where a lot of just kind of the different perspectives of different people and different teams comes in, is asking, how are we going to know something's broken, right? What monitoring does this need? What Nagios checks does this need? What stats should be collected? If it breaks, am I going to get paged? If I get paged, how am I going to know what to do? All that gets asked up front. And to beat a dead horse, when you ask that up front, it's much easier to deal with than when you're about to deploy the system and then somebody goes, hey, so if that cron job doesn't run, what happens, right?
Is that part of those checks you showed in your review?
Partially. So usually from a systematic level, that conversation happens before there's even any code written. So there'll be a high-level thing of okay, well, we know we're going to have this database involved, and we're going to have these processes involved, and there'll have to be this thing happening periodically. So we'll develop basically, as part of the requirements for the system, know that we'll have to have checks here, here, and there. But then potentially, the main place where that checklist gets involved is, let's say, so actually in the case of that Mongo system switchover I was talking about, what that checklist would have consisted of would be the steps of okay, so we're going to bring up the new system. We're going to start doing writes into that system. We're going to do whatever steps we need to copy over the data. And then we're going to switch reads. And then we're going to do this to get confidence that the reads are everything's working right. And then we'll kill the old system. Okay. That's what would be in that checklist. So
that's more for structural big changes than on the 20 a day.
For the most part, I mean, there's different levels. That one's pretty involved. A lot of times what we'll do, what that checklist for the smaller stuff will consist of is what the validation steps are, right? So there are ways things can break which won't necessarily set off checks, right? If some CSS is kind of, at least with our current testing, that's probably not going to set off an alert, but it'll piss off a user. So we define what those checks look like.
So you use Jenkins for build, and what are sort of the things you use for checking?
I'll get to that. And actually, this touches a little bit on, I'll get into a bit more now. But so kind of continuing on that, once we know something's broken, what do we have to have in place to figure out what's wrong, right? What needs to be logged? Where is that logging going? And what has to go into our stat system? We're at NYC, we use Graphite a lot. I forget the exact number, but we're in the billions, if not tens of billions of increments a day for our Graphite cluster. So again, when I get that page at 4 o'clock in the morning and I get an alert saying, hey, this thing's broken, what's the next step? How do I figure out where to go next? What operational options are there for dealing with failures, right? So different systems are going to look different ways when they fall down or when systems they care about go down, right? So let's say a box for a particular service goes down. Does that mean that we need to pause queues so we don't lose data while we handle reprovisioning the box? Or is a particular class of machine stateless and we just spin up a new box, right? Like, what do those failure scenarios look like and how do we deal with that? And where do I find that information is kind of questions up with that. Next question is, how available does the system need to be? One of the other nice things about an SOA type system is we can have different availability guarantees for different services. So as an example, our decode service has massive redundancy built into it. We're at the place where even if our primary data center literally falls off the face of the planet, we could be up and redirecting within a few minutes, right? On the other hand, some of our, like our Hadoop cluster, which is primarily used for research tasks at this point, if it goes down for an hour, it's not awesome. Some people are going to be kind of annoyed internally, but not the end of the world. We don't need to spend more resources making that more available. So we kind of have that conversation about kind of cost benefits, both in terms of literal costs of actual hardware, as well as like dev time and attention. And then, I guess I kind of had that redundantly. Anyway, again, pay a lot of attention to failure scenarios, because that's where stuff gets squirrely. Oh, sorry, this is speaking to how failure of other systems is going to deal with it. How can we route around failure, right? So if this is querying another system and one of the boxes in that system goes weird, what impact is that going to have and how do we deal with that? One of the ways we deal with that is we have a library called hostpool. It's open source. This one's Python. Somewhere we have a Go one. I forget what the link is. You can probably find it. And the idea there is you can kind of think of it as an in-application load balancer. In the sense of the way it works is you'll say, instead of saying this is the just URL I want to query for the other system, you can say that this is the pool of servers I want to query for a system. So when you do a query, you ask for a server to query, you do it, you do your query, and then when you get the response, you either say that worked or it didn't. And the library then kind of in memory just keeps track of those success rates and then increases the probability that healthy servers will get queried. Effectively allows things to self-heal and self-route around failures. Obviously, you want to have monitoring in place to know when that happens because self-healing only goes so far and having broken stuff out there is not great long-term, but it helps deal with stuff while the slow humans are figuring out what's going on. Similarly, NSQ has a lot of capacity for routing around failure. That again, if you're interested, I can talk about later. What hardware will this require? Again, kind of going back to the SOA discussion. Can this be okay on a C1 medium, or do we need SSDs? Do we need more memory? What do we need here? And similarly, is what this is going to be doing going to justify the costs associated with that? At least have an understanding of what's involved in adding capacity. A lot of times we'll build systems so that for the next 6 months we'll be fine. But what's going to happen if either we get more traffic than we expected or those 6 months go up, right? Sometimes it can be nice, and like if it's just a nice stateless service, the answer is throw more hardware at it. Awesome, great. Throwing money at the problems is always a fantastic answer. But other times it's harder, right? Like if you have just a MySQL database, throwing hardware at it is kind of not easy to do, right? So what does that process look like? And if not having the tooling in place right now, understanding and documenting what the avenues are for a given system is important for us. Again, similarly, there's often, when we're building new services, asking these questions up front allow us to make relatively easy to make changes from an architectural standpoint that, when asked at the beginning, make things down the road much easier. But if you did it later in the process, would involve like redoing stuff, right? We also, since we run in 2 data centers, we have the question of what data center should this run in. There's a certain amount of, there's some situations where cost performance is better for the physical hardware than the virtual. In particular, RAM and disk space is a lot better for the physical for us. For CPU-bound stuff, it's kind of the same. Actually, the bigger thing for us often is understanding what other services this is going to be chatty with. So if there's another service that this thing is going, with this new service is going to be chatty with, it would probably be nice to not have that chattiness going over public networks and just staying on the LAN. So a lot of times we'll try and co-locate services that rely on each other a lot. Similarly, kind of relatedly, we ask what impact a new service is going to have on other systems. Right? If something's going to be increasing the load on a system by 10x, that other system's probably going to care about that. Right? So we have to work through the implications of that. Again, most of the time, not too bad if we ask it up front. But if you didn't ask the question, launched it, and all of a sudden that system has 10x the load, that's probably not going to be an awesome day. And the last question we try and ask is, will there be any ongoing operational tasks? Obviously, we try and build systems so that they more or less take care of themselves. But sometimes, especially for the first 1 or 2 iterations of a system, it makes sense to just have an ops task happen every 6 months, right? We have a system that like archives the raw data that will crawl off the internet. And it turns out doing exploration of billions of things is really, really hard, just computationally. And the easiest solution we found is just to have that like crawl cache off a bunch of EBS mounts. And every couple of months, just format one of those mounts and call it done, right? Like, it's just there. And we just, at this point, like, it's a rare enough thing that's easy enough that it just hasn't made sense to build the tooling for. But we want to understand that and make sure we're doing that cost trade-off equation of, do we need to build the tooling to automate this, or can it just be an operational task for now? Now, getting back to the gentleman's question, monitoring the scary stuff that's going to wake us up in the middle of the night. So for alerting, we use Nagios. It is bizarre. It is Byzantine. It literally takes you 8 months to figure out where on earth stuff is in the interface. But it is solid as a rock, and once you damage your brain to understand it, it's fine. And at least for us, like, we have enough grizzled, gray-beard ops people that they knew this off the bat. It was the easy answer for us. If it's not Nagios, you need something that, when something breaks, will notice and wake you up. Because I forget who to attribute this to, but there's a great quote of, if you don't have a Nagios check on something, it is probably broken and you just don't know about it yet. If you're not actively checking things and making sure they're doing what you think they are doing, it's almost certainly broken in some way. Something actually that's interesting that we've started to do more aggressive recently is, in addition to doing kind of the obvious Nagios checks of is stuff up, are server metrics within normal bounds, right? We're not swapping out or whatever. We've actually started adding data integrity checks into Nagios as well. We've actually run into situations where services will be up and look like they're operating right, but be telling you dirty, filthy lies when you ask them things. And that's obviously not great. So we added Nagios checks to make sure that's not happening. Something to think about. Graphite, again, we're at Etsy. Thank you. We use this a ton. Pretty much anything that we care about in aggregate, we add metrics on. A lot of times we'll even just instrument stuff in Graphite just because it might be interesting. We actually spend a decent amount of money on our Graphite cluster, but that's just because we throw a lot at it. And then we also are then able to pull that data into other things very easily. So this is an example of a dashboard. That's basically just a health of our API, right? And it's just kind of stuff you would expect, right? Unknown errors per minute, 99% times, 95% times if you look down the mean times in there. Again, if any of those are going up and to the right, or if there's a big spike in there somewhere, you probably want to look at it because stuff's broke. This is actually the kind of stuff that we're starting to work on adding physical, just like dashboards and like TVs into our office. So you have that awareness of like, oh, hey, you just go to get coffee and go, oh, hey, there's a big spike 10 minutes ago in our mean response time. What's that about? Digging into that. Centralized searchable logs are really powerful. Right now we have a ghetto wrapper on grep. Hopefully soon we'll be switching to Logstash and Kibana, basically like an open source Splunk, but that's where we are today. Under the set covers syslog, getting everything to one place. But having everything, like all your public requests into Bitly go into a cluster of 24 servers. If one of them is having errors, figuring out which one of them is going to take some time. If you have to log into each of them individually, having your logs in one central place where you can search things is pretty powerful. And to wrap things up, some quick final thoughts. Be deliberate. Make sure you're doing things for a specific reason and not just throwing shit at the wall. Kind of in the same vein, understand why you're doing something. Like, it's really easy to just look up the random searches on Flickr for Creative Commons stuff. Is fantastic. It's really easy to like have a problem, do the Stack Overflow search, and find a solution, but not take that extra step to understand why that solution addresses your problem. Take that extra step. It really pays off big time. Certainly work through the details. I mean, obviously, there are limits on all this. If you take this to an extreme, you'll just be digging into like how your specific compiler and processor are working, and that's probably not productive most of the time, but maybe go a layer or two deeper than you absolutely have to understand what's going on. It really both helps further you as a developer and make sure that you are doing what you actually need to be doing. And finally, a quick shameless plug. Bitly, shockingly, we're hiring. We really want to talk to you. We'd love to talk to you. Come talk to me afterwards or check out bitly.com/jobs. And if that, any questions?
You mentioned an open source equivalent as well.
Logstash and Kibana. So Logstash you can kind of think as like a thing that routes streams of logs and makes it easy to push stuff into Elasticsearch. And Kibana is like a UI on top of Elasticsearch that's optimized for logs. We've had some quirks implementing it, but that's more quirks of our infrastructure and those particular tools.
I imagine you guys weren't always this.
Yes.
How long ago did you guys start to transfer to this kind of mentality? And like, do you have any like, not like, oh my God, what was all your things, but is there one thing that you can remember that really kind of moved forward towards this thought process?
Sure. So, sorry, I've been doing a bad job of this. I should be repeating the questions. So the question is, obviously, Bitly hasn't always been doing this. How do we get here? And if there's been any particular critical moments in that path. For better or worse, actually, a lot of this was already in place when I joined Bitly, at least from a high level. A lot of it has been a matter of having a culture of caring about process, but also having an allergy to enterprisiness, right? And that definitely creates tension, right? There a lot of times when something goes wrong, there's a very easy answer of developing a process to not do that again, right? But if you do that all the time and take that easy answer, you end up with this, like that's how you end up with like the crazy, like, you know, enterprisey world type stuff, right? So a lot of it basically comes down to caring about process, like, and thinking about things in those terms. Being willing to take the time to figure out if there is a, I hate using this word, but more elegant solution than just making process to not do that again. And doing things iteratively. Something else that's kind of interesting of this for especially like lean type folks, it wasn't, I don't think, done in quite that intentional of a way, but just intuitively as the way we work. Virtually none of this was done like as a fundamental change and by fiat. A lot of it has just been kind of incrementally done as needed over time as the team's grown. I don't know if that answers your question.
Completely answered my question. That's what I was.
Cool. I think there was a question in the back.
So you mentioned being an SOA shop. When new services come online, how do you deal with kind of responsibility and ownership? Who gets the data for those? So
this is again a place where I suspect we're cheating by our size. Right now, there's just one on-call rotation, and whoever's on call gets the alerts, period. We have started to talk and think about potentially having more directed ownership like that, but we haven't gone there yet. And for the most part, thankfully, it's relatively rare that new systems break at 4 o'clock in the morning. I guess via the rest of our process and doing stuff like doing partial, like especially for backend systems, a lot of times part of our validation process, like let's say I'm rolling out a change to how a particular like user-facing API is implemented that doesn't have any functional changes to the user, but changes how we do things internally. A lot of times we'll just deploy that to 1 or 2 servers, let it soak for a day, and then push it out. Like doing stuff like that makes it pretty rare that new systems cause problems at 4 o'clock in the morning.
How are you deploying? Just Python scripts you deploy? RTM files?
Yes, thank you. So the question is how we are actually deploying. How to describe it. So like I said, it's a homegrown system that when you kind of squint hard enough and look at a high enough level of abstraction, it looks a lot like Chef and Puppet. The particularly interesting way that's the case is there's basically a series of tags that define what a series should be, which then run a series of idempotent install scripts that will basically, the tags will basically say like, so the process that does redirects for us is called NSD, right? So we'll have a tag that says NSD should be running on this box and should have like 4 copies of that process running, right? So the install script will basically go through and say like, okay, is the version that I expect installed in the box? Yes, great, I'll just move on and not care. No, okay, let me do whatever I gotta do to get the box closer to the desired state. At that level, it's pretty standard. How we actually go about implementing it, it's basically a giant pile of ash with some tools to make it easier to do the idempotent stuff. And most of the time, we try and work with whatever environment's toolchain. The Python stuff is a little non-standard, but that's mostly just because, like a lot of why this stuff is homegrown is not because the existing tools are inadequate, it's just they didn't exist when the stuff was built. And like the migrating cost is not justified. But yeah, a lot of our binary stuff gets installed via RPM. We're running CentOS 5 something in most places. A lot of stuff we just run our own binaries for. But a lot of the Python stuff gets a fairly standard install. Sorry.
You mentioned Chef and Puppet.
Yep.
Do you use both?
We use neither. I just use those examples and that approach of basically having something that defines what a server should be and then having a series of idempotent scripts to get it closer to that state is roughly architecturally what our system looks like. The actual implementation of that is just all homegrown.
I wanted to ask you a little bit more about your approach to SOA.
Yep.
So obviously if you break your system down into a lot of small, very simple services, those services individually are very simple. But if you have to join lots of moving parts together, there's potentially architectural complexity there, which gives rise to strange network effects and side effects and that kind of stuff. Coupled with the fact that if you have lots of different systems and different languages using different tools, organizationally you've got to manage that complexity as well. Where do you see the sort of the healthy balance in that tension?
Sure. So to paraphrase the question, how do we manage complexity in SOA? On the system side, we get to cheat a ton because our data is effective. The lion's share of our data is immutable, right? So the fact that we don't have to deal with changes or deletes makes a whole lot of problems way easier, right? Because denormalization at that point is dumb simple, right? Like you just get a copy of all the writes that happened and you're done. It's easy, it's great. So there are a lot of things where we just don't have that problem, which is somewhat cheating on our part, or just, maybe not cheating, but taking advantage of the situation we're in. It definitely is a more complicated situation for other people. We do run into some of that as far as joining data sets, right? So actually a lot of the quirks in the existing Bitly interface as far as like, well, why can't I just filter my links by this, that, and the other thing? The answer is because that's in 5 different systems and doing joins across databases is not a thing. And so the answer there is usually if we have to do a new kind of combination of data, that means a new service. As far as managing complexity from a tooling standpoint, it's a lot of basically self-discipline. There definitely was a phase at Bitly where we had a database of the week problem. At this point, we basically have all the open source databases except for Postgres, and even now that we have Redshift, we have a weirdo flavor of that. But at least in the time that I've been there, we've done pretty good about effectively, if somebody proposes using a new data store or a new language or a new platform, asking the hard questions to justify it, right? So, and actually that's one of the things I really like about Bitly, is the culture is very much in a place where making those proposals is totally okay, but you better be able to justify your position, right? If you want to bring in a new database, you better be able to damn well explain why one of the ones that we already have a bunch of experience in tooling in place are inadequate. Similarly, if you want to bring in a new language or platform, you have to be able to answer those kinds of questions. We've also started, at least for databases, I don't think we intentionally did it, but it's kind of happened. If you bring in a new database, you're on the on-call rotation. So that also kind of helps keep people using what's there. But yeah, it definitely is a struggle. That's something we have to work with. Cool. Sorry, I'll get this out and then.
So you mentioned that Jenkins report build statements back to GitHub.
Yep.
So I wonder how exactly what the
So we're lazy and we have an unbelievable Java/JVM allergy at Bitly. Sorry, so the question was, how do we actually handle getting the commit status stuff back out of Jenkins? So we have this bordering on irrational JVM allergy at Bitly. A lot of it comes down to just getting burned a few times in the past and then not being lazy and not wanting to have to learn how to do JVM tuning because we don't have experience in that. Accordingly, for certain styles of that workflow, there are plugins for Jenkins that'll just do it. We ran into some quirks in that since we do so many, like we try and keep our pull requests small, accordingly, I think we're up to issue number, I forget, we're in like the 2500s on GitHub. Just as a quirk as GitHub implements ways to actually pull down that pull request code, it breaks a lot of the existing plugins. So we basically have a sidecar service that uses the GitHub commit hook API, and then Jenkins has a similar thing where you can subscribe to notifications about things that happen inside of Jenkins, now basically handling the messaging back and forth. You entirely could implement it as a Jenkins plugin, but we hate Java, so. I think there was a question over here.
you mentioned staging environment.
Yes.
Can you describe what you moved from dev to staging to production?
Sure.
And also, do you have QA and are they involved in that process? Or just based on question?
Yep. So there's some interesting there. The question, to repeat it, was basically what does our staging environment look like and what do transitions from dev to staging and prod look like? So we have some interesting quirks in there. The most prominent of which is for us, staging is generally staging of code, not of data. So our staging environment actually queries production databases and production backend systems in a lot of cases. A lot of the reason for that is to basically deal with the SOA complexity issue. One of the drawbacks of an SOA setup is it's unbelievably difficult to have a consistent subset of data across your entire system, right? Because since your data is split into, let's call it 36 services, they each have their own snapshot or slice of the data that the system overall has. Therefore, getting a consistent slice of that to have a subset of that infrastructure for a full-on like normal staging environment is extremely difficult. And running a mirror setup is, since we see, like I said, I think it works out to about 3,000 decodes per second as like a normal stream. Like having the staging system that can handle that is basically doubling our servers, and we just can't afford that right now. So we have the quirk of that weird staging, it's just code, not data. Most of the time it works out okay. Our dev environments are, we just use VMs. So we actually use the same deployment infrastructure all the way from dev up to production. We try and keep our dev and staging environments as close to production as possible, obviously with the exception of actual like network separation kind of issues and hardware capacity. And the way the promotion process works is basically developers will work on the local VM, get it to a place where they think, excuse me, it's useful, push that up to GitHub. They'll start running in Jenkins. Jenkins runs against effectively dev environments. Then we use HipChat internally, so we have a HipChat bot. I think it's based off a HuBot, where you can reserve staging. If you need to, you can push your code there. We've gotten to a size where we started to run into some issues around staging contention, so we're probably going to have to figure out a different approach for that soon. We're still working through what that's going to look like. For front-end code, there is still some manual testing. We don't have any formal QA people. Some of that's by design. Some of that's we're desperately trying to hire people. The design part is we're fairly against the idea of having humans who their specific job is to just go and click on things. That's just both, if we want to do as many deploys as we want to do, that's too slow, too inconsistent, and just people-wise, like those are salaries that can go elsewhere. So we really focus on automation of testing. So we're really trying to hire basically a lead QA engineer to help build out that infrastructure to be better than it is, particularly around front-end code. Right now, our front-end testing is not where it needs to be. But accordingly, to deal with that, a lot of times when a code change goes out, that affects front-end stuff, the developer as well as other people on the team, they'll say like, hey, the code's up on staging, go check it out. We'll do some manual testing, and it goes live. But most of us rely on automated testing.
You do it 20 times a day, so it's not like 20 times a day someone might checks.
It depends. I mean, so a lot of those pushes might be operational stuff, it might be back-end stuff. Those, the automated testing is much better coverage, in which case you don't have to deal with the manual testing. So it kind of depends. I think there was a question over here, and then I'll. Oh, yeah.
So using tools like Jenkins, which are great, but they're only as good as the developer's tests. So do you do some type of analysis that checks how much of the code, some type of code coverage before you accept it as good enough to actually be pushed up? Like, what if somebody builds something and you decide you only have 95% of the code tested? Is there an acceptable number, or is every single thing have to be tested?
Yeah, so the question is basically, who tests the testers? How do we have confidence in the automated testing infrastructure? Right now, we don't rely too much on coverage metrics. It's basically a manual part of the peer review process. So the review absolutely includes tests. And a fair portion of the time, at least the reviews I do, are like, hey, so tests about those. Or like, obviously, if there are tests in the pull requests already, having questions about like, how is this covering things? Is this focused enough? Does it broadly handle stuff? One of the things that we're still struggling a bit with that, again, is kind of hard in the SOA environment is kind of integration versus unit tests and the value of each of those. So we're still kind of working through getting more consistent about some of that. But mostly it's the peer review process. And culture and shame. If you have something that doesn't have tests, then you get shamed.
So I was just curious, you mentioned like operational changes versus code changes. You seem to indicate that. So what would an example of one versus another?
I guess this might be a case of Bitly vocabulary leaking out to the outside world.
Yep.
So the question was, I've been talking about operational changes versus code changes, and what does that mean? So I apologize for that internal vocabulary leaking. Not that it's precious or anything, it just doesn't mean anything to anybody else. It's mostly the intent or the purpose of a change, I guess, is where that kind of ends up falling out.
So, I mean, I have an idea what it could be. I'm just curious what your idea would be.
Sure. So examples of that, I guess a lot of it comes down to who on what teams are doing stuff and why they're doing it. So an example would be a change we made recently is the authoritative database of what a short link to a long URL and vice versa is basically this big sharded MySQL cluster doing application level sharding. And that cluster started to run out of disk space. Happens after 5 years. So we had to grow that. And when you're growing sharding, that usually is not trivial. So there was significant code changes involved to grow that cluster. That was largely viewed as something that the ops infrastructure team was owning and so on. So that might be a case of what I was talking about there.
Okay. So the question is would somebody operationally make a change on an individual server, or would they basically push a change to a group of servers? So
effectively, it's always the latter. The group might happen to consist of one server, but I'm sure there's some exception somewhere that's happened. But if somebody were to SSH onto a server and change the code locally, they would be shamed to oblivion at Bitly. Like, that's just not a thing. Everything happens through SCM. Everything happens through Git. Everything happens through the deploy process. A lot of that has to do with that kind of joint state stuff of having to have that history and have that consistent view of the world. A lot of it also has to do with, like, we really rely on that documentation, right? Like, being able to go back and see when things were changed is, like, if I went onto a server and found code that didn't match the Git commit that's checked out there, like, there's a deep issue, and whoever did that is having, like, we're having a conversation, right? Like, that's just how we do stuff. And a lot of it comes down to when you have so many people touching so many different pieces of a system, if you can't go back and have that basically audit trail, like, things become unmanageable very quickly.
change management?
Yes. That's our current form of change management, basically.
Yeah.
If you didn't have any of these mechanisms in place, which would you implement?
The peer review with the button rule. By far, that is my favorite thing about how we do things at Bitly, and the thing that really enables a lot of the other stuff.
Can you just explain the button rule again?
Whoever wrote the code is not allowed to merge the code. So everything happens through pull requests, and I mean everything. Nobody makes commits to the master unless somebody literally broke Git and we're fixing it, which has happened maybe twice. For us, there's a lot of ways where we're able to avoid process through discipline, and that process is the mechanism for having institutional discipline, if that makes sense. I think there was a question over here, quick. Yeah.
How do you decide if something is a new feature of an existing service or an entirely new service?
That's an interesting question. The question was, how do we decide on a feature in an existing service versus building a new service? A lot of it for us comes down to how data needs to be persisted and how it needs to be queried. When you get to the scale of Bitly, for a lot of things, the only way to have reasonable user queries is to pre-aggregate things. So that's what a lot of our systems are doing various forms of pre-aggregations. Like basically, like for your click count at Bitly, we're not doing select count star because that database would have hundreds of billions of things in it at this point, and that's not a query that's going to happen in a request response cycle, at least to any user for us. And accordingly, we kind of increment counters as the clicks come in, and then we just tell you what the counter says. So a lot of it comes down to, yeah, basically that equation of like, does this fit within a persistence and a query model that an existing system has and make sense in that realm of roles and responsibilities? And if not, then it means a new service. And new services are not uncommon or a high barrier for us. We probably create a few every month. Well, not every month, every few months. I know I keep on going. I don't know if you guys have any kind of time limit. I'm happy to keep going, but. Sure. Okay.
So you have a solid process and works well for you. So based on what's working and what's not, what's next? Is it just incremental things like better usability testing, or are there big things that you would want to improve?
Yeah, that's an interesting question. I guess with an ops focus, one of the biggest things for us is that staging congestion issue. We actually are starting to run into situations where devs are sitting around twiddling their thumbs for unacceptable periods of time waiting for staging to become available. So we're really starting to try and work through that. We have some capacity issues, just systems that were built a while ago that were intentionally designed with certain limitations that we're starting to run up against, so we just have to make changes to deal with that. We've mostly worked through with the current issues with it, but the DDoS stuff has been really big for the last, I guess actually since January. We've been dealing with a number of DDoS attacks and getting that process down. Huh?
You should help the meetup.
We've actually been talking to some other people who have been getting hit. Yeah, it's tough. Yeah, if anybody's interested in talking about some of that stuff, I'd be happy to talk about that afterwards. But yeah, it sucks. Just, that's all there is. Is there another question? Awesome. Cool. You all have been great. Thank you.